Here we're looking at simultaneous equations, and we're talking about how to find, how to work with them, but graphically. So there's 3 steps to this. We have to draw a number plane. So I've done that already for our example. We have to graph both equations, and we have to read the point of intersection. So in order to graph both equations, I've made up 2 x and y tables. Now in the example, the question asks find the simultaneous solution of y equals x plus 3 and y equals minus 2x. So we're going to fill in this table and draw it on the graph for y equals x plus 3, and then we're going to do it again for y equals minus 2x before we can read the point of intersection. So to start off, I'm going to type into our calculator, I'm going to type in, wherever I see an x, I'm going to put in brackets, so it's x plus 3. So in those brackets, I'm going to replace the inside with whatever's here. So in this case, it's minus 2. The answer is going to be 1. And if I go back in, I'll change it to minus 1. We get 2. Go back in, change it to 0. We get 3. Change it to 1. We get 4. And go back in, change it to 2, and we'll get 5. So that's what we get for our first one. So let's plot these points. Now, first at minus 2, x is minus 2, we plot positive 1. So I'm going to do that there. Sorry, these should be positive. And then we've got minus 1. We have a positive 2. At 0 we have a positive 3, so it's going to be about there. And I've run out of space, but that's enough. As long as I've got 3 points, I can graph them. So that's our line there. And that, I'm going to label it, that's y is equal to x plus 3. Now I'm going to do it again. I'm going to do it again for the bottom one here. We've got y equals minus 2x. So I'm going to do the same thing. I'm going to type it into the calculator, but replace the x with brackets. And I'm going to change these values. So we have minus 2, pop it in with the brackets. We get 4. Change it to a minus 1. We get 2. Change it to a 0. We get 0. Change it to a 1. We get minus 2. And change it to a 2, we get minus 4. So now we've got those, we can graph them. Here if we've got minus 2, we have 4, so that's going to be up here somewhere, probably about there. At minus 1, we've got a positive 2, so that's there. At 0 we have 0, at 1 we have minus 2, and at 2 we have minus 4, so that's going to be about there. So I'll try my best to graph these. It's a little bit off there, but close enough, just to get the idea of what we're trying to get across. And what we can see is that there's one point of intersection, that's here, this point here, and now we've graphed both equations, we can read off the point of intersection. So what that means is the point of intersection is the point where both of these lines meet, and in this case it's minus 1, positive 2. So minus 1, that's our x value, and 2 is our y value. That's our x value and that's our y value. And that's all you need to do. You need to have to be able to draw the number plane, graph both equations, and read off the point of intersection. Now, if you aren't required to graph these 2 equations, you can still find the point of intersection sometimes if you actually have them in your table of values. You'll notice here that minus 1 and 2 and minus 1 and 2, they're the only things in common with these two tables of values. So we can actually identify that it's going to be -1 and 2 from here. However, the question did ask to actually graph them, and this is a good practice for that.